Hi friends, see in work power energy part 1 we have discussed about up to power formula and also various type of steps in power in different forms of power. Now in part 2 work power energy we will be discussing about work energy theorem and mechanical energy in different cases. Okay, so in part 2 we will be discussing about work energy theorem. Now what is work energy theorem? Very simple. See here, work done by all forces is equal to change in the kinetic energy delta Ke. All forces and ఏంటి ఇక్కడ work done by conservative plus work done by non-conservative forces. Work done by all forces అంటే ఏంటి ఇక్కడ work done by conservative forces plus work done by non-conservative. Conservative ఏంటి gravitational force. ఓకేనా, ఎగ్జాంపుల్ చెప్పాను కదా, గ్రావిటేషన్, స్ప్రింగ్ ఫోర్స్, ఎలక్ట్రోస్టాటిక్. నాన్ కన్జర్వేటివ్ ఏంటి మీకు చెప్పాను, డ్రాగ్, ఎయిర్ రెసిస్టెన్స్ అండ్ ఫ్రిక్షనల్. సో దీస్ ఆల్ ఫోర్సెస్ ఈజ్ ఈక్వల్ టు చేంజ్ ఇన్ Ke, or simply you can write it as half m v square minus half m u square is equal to work done. Okay, so work energy theorem అంటే ఏంటి, work done by all forces, that is conservative forces and non-conservative forces like gravitational force, frictional force is equal to change in kinetic energy. Okay, so we can write as a mathematical form W is equal to work done as half m v square minus half m u square. Initial kinetic energy, final kinetic energy. Clear? Right. So this is about work energy theorem. Now let us go into the last part of this work power energy in part 2. Last part ఏంటంటే మెకానికల్ ఎనర్జీ. అంటే అర్థం ఏంటి, దిస్ లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ ఈజ్ కాన్స్టెంట్ అని మనం ప్రూవ్ చేయబోతున్నాం. దట్ ఈస్ ఇన్ ద కేస్ ఆఫ్ టూ కేసెస్. వన్ ఈజ్ ఫ్రీలీ ఫాలింగ్ బాడీస్. ఒకటోది ఏంటి చూడండి, జాగ్రత్త చూడండి, ఫ్రీలీ ఫాలింగ్ బాడీస్. అండ్ సెకండ్ వన్ ఈజ్ వెర్టికల్లీ ప్రొజెక్టెడ్ బాడీస్ అండి. మీకు అర్థమవుతుందా, వెర్టికల్లీ ప్రొజెక్టెడ్ బాడీస్. ఈ రెండు సందర్భాల్లో మనం ఏం చేయబోతున్నాం, వీఆర్ ప్రూవింగ్ లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ. అంటే టోటల్ ఎనర్జీ అంటే ఏంటి, టోటల్ ఎనర్జీ అంటే టోటల్ మెకానికల్ ఎనర్జీ ఈజ్ కాన్స్టెంట్, దట్ ఈస్ పొటెన్షియల్ ఎనర్జీ ప్లస్ కైనటిక్. పార్ట్ 1లో మనం డిస్కస్ చేస్తాం, తెలుసు కదా, పొటెన్షియల్ ఎనర్జీ అంటే ఏంటనేది, అలాగే కైనటిక్ ఎనర్జీ mgh అండ్ హాఫ్ m². ఈ రెండు టోటల్ చేస్తే మెకానికల్ ఎనర్జీ వస్తుంది. అది ఈ రెండు సందర్భాలు విల్ బి ప్రూవింగ్ దట్ ఇట్ ఈస్ కాన్స్టెంట్. సో ఫస్ట్లీ విల్ డిస్కస్ అబౌట్ ఫ్రీలీ ఫాలింగ్ బాడీస్. ఇన్ ఫ్రీలీ ఫాలింగ్ బాడీస్, అబ్జర్వ్ హియర్, ఐల్ డ్రా ఎ స్మాల్ ఫిగర్. సో లెట్ దిస్ ఈస్ గ్రౌండ్ and let the body having mass m is falling freely. When any body is falling freely, the initial velocity is equal to 0 always. So let this point be A, and intermediate point B, and the lowest point, ground point, be C. Okay, so మొట్టమొదటిగా ఏ నుంచి ఒక బాడీని ఫ్రీగా పడేస్తున్నాం కిందకి, ఫ్రీలీ ఫాలింగ్ అంటారు. ఫ్రీగా పడేస్తున్నప్పుడు ఇనిషియల్ వెలాసిటీ 0 కదా. సో ఇక్కడి నుంచి స్టార్ట్ చేస్తాం. విల్ స్టార్ట్ ఫ్రమ్ ఏ. at A, what is P? Potential mgh, that is mg into A. ఎంత హైట్లో ఉంది, let it be height at around h from ground level. Let the total height be h. So mg into h, that is mgh. That is the total, potential energy at point A, which is falling freely from point A. Now we have to calculate Ke also. What is Ke? That is half mv square, that is equal to half into m into see here. So at A, now what is the kinetic energy formula? Half mv square. And ఏంటి, half m. What is the velocity, initial velocity freely falling body? 0. So 0 whole square, that is equal to 0. So at A, చాలా జాగ్రత్త చూడండి, చాలా ఇంపార్టెంట్. ఇంటర్మీడియట్లో ఇది 4 మార్క్స్ రిజర్వేషన్ ఐపీలో. So at A, total energy or total mechanical energy, P PE plus KE అంటే PE ఎంత వచ్చింది mgh plus 0 that is equal to mgh, equation 1. So at A we have proved the total mechanical energy is equal to in the form of potential energy for freely falling body. Now let the body has traveled from A to B over a displacement of say x. Let the body has traveled from A to B over a displacement of x. So అప్పుడు ఏమవుతుంది at B potential energy mgh. Now at height B, what is potential energy from definition? Definition ఏం చెప్తుంది? With respect to center of mass, it is energy possessed by the virtue or state with respect to center of mass. అంటే ఈ height ఎంత అవుతుంది అప్పుడు మనకి h minus x. So this height with reference to ground level you have to take always potential energy. So ఈ height దగ్గర ఎంత అవుతుంది మనకి mg h ప్లేస్ లో h minus x, that is equal to mgh minus mgx. This is PE at B. Now what is KE? Kinetic energy. Half m into half, when the body is falling free, the velocity gradually increases. So e point that let the velocity be v. Let the velocity be v at B. So half m v square, that is equal to half m v whole square. But what is this velocity here? See, when the body is falling freely, a is equal to plus g, u 0, v is equal to v, okay, and displacement in the s is equal to x. Substitute all these in the equation v square minus u square is equal to 2s, kinematic equation, లేదా v square minus 0 whole square is equal to 2gx. So v square ఎంత వచ్చింది మనకి 2gx. So substitute here half into m into v square, that is 2gx. 2 gets cancelled, ఏం మిగిలింది మనకి mgx. So what is kinetic energy at point B? mgx. Now total energy, mechanical energy. So total energy at B is equal to PE plus KE. P ఎంత వచ్చింది చూడండి mgh minus mgx plus mgx. mgx minus mg gets cancel, ఏం మిగిలింది మనకి mgh. ఈక్వేషన్ 2 చూడండి ఏం జరుగుతుందో. ఈక్వేషన్ 1 mgh, ఈక్వేషన్ 2 mgh. సో ఈక్వేషన్ 3 కూడా ప్రూవ్ చేస్తాను ఇప్పుడు. అది కూడా మనకి పొటెన్షియల్ ఎనర్జీ ఫామ్ లో ఉంటుంది. నోట్ చేసుకుంటున్నారా? నోట్ చేయండి ప్లీజ్. ఓకే 1 2 3 రైట్. నౌ let us go to the last one at ground level. At ground level here. Now see, in the first case and second case the values are same, mgh only. Now let the body has traveled from A to C just before touching the, ఎందుకంటే టచ్ అయిపోయింది ఏమైంది సున్నా అయిపోతుంది వెలాసిటీ. సో అందువల్ల వాట్ యూ హావ్ టు డూ, వీ షుడ్ నాట్ టేక్ టచింగ్ ద జస్ట్ బిఫోర్ టచింగ్ ద గ్రౌండ్. So let the body before touching the ground, its velocity be say v1. Okay. Now we'll try to calculate at C before touching the ground. At C before touching the ground. Okay. So now P, మళ్ళీ ఎప్పటిలాగే PE is equal to mgh. Ground level height ఎంత ఉంది సున్నా, no height at this level. So into 0, that is 0. Now KE is equal to half into m into just before touching the ground, ఎంత అనుకున్న velocity v1. So v1 whole square, that is equal to half m v1 square. But here once again body has travelled down how much distance? S is equal to h just before touching the ground, a plus g, okay, u initial 0 and v has become equal to v1. Substitute all these again into kinematic equation. V square minus u square is equal to 2as. So v square means v1 square minus 0 whole square is equal to 2gh. So v1 square how much వచ్చింది మనకి ఇక్కడ 2gh. Substitute here. So half into m into what is v1 square 2gh. 2 gets cancelled, ఏం మిగిలింది మనకి mgh. Now once again total energy or mechanical energy at ground level before touching the ground, C is equal to PE plus KE. P ఎంత 0 plus K ఎంత వచ్చింది mgh, that is equal to mgh. Equation 3 you can observe equation 1, equation 2, equation 3 all are equal to mgh. What does it mean? That means for a freely falling body the total mechanical energy, that is PE plus KE, is constant. Therefore this proves the law of conservation of energy in the case of freely falling bodies. Now let us go please, let us go to the next case in this one. Let us go to the next case, that is vertically projected bodies. Okay, please copy it. Now same thing I'll interchange. Now we'll go to the next case. That is called as vertically. That means same law of conservation of energy will be proving for vertically projected bodies. Okay, na చూద్దాం మరి చూడండి. Same ground level. Let this point be A. Let a body having mass m projected with a velocity say v. Let the intermediate point be B. Let the highest point be G. When a body is projected to the highest point, what is the final velocity? Final velocity is always 0. Okay? ఇప్పుడు ఏ నుంచి ప్రొజెక్ట్ చేశారు మనం ఏం చేయాలి ఇప్పుడు వెర్టికలీ ప్రొజెక్టెడ్ బాడీస్కి లా ఆఫ్ కన్జర్వేషన్ కాన్స్టెంట్ అని ప్రూవ్ చేయాలి. అంటే ఏ దగ్గర బి దగ్గర సి దగ్గర యూ హ్యావ్ టు ప్రూవ్ దట్ at all points A, B and C the total energy or mechanical energy PE plus KE is constant. So first I'll try here from A. I'll give some values here. Total height H అనుకుందాం. Let the total height be H. Now at A మళ్ళీ ఎప్పటిలాగే at A PE mgh formula m into g. At A అంటే గ్రౌండ్ లెవెల్ హైట్ ఎంత ఉంటుంది 0. So 0 that is equal to mg into 0 that is equal to 0. So at A potential energy is equal to 0. Now K formula and half m with how much velocity projected upwards v. So half m into v square that is equal to half m v square. So what is total energy? Total energy at A is equal to P at A plus K at A. P ఎంత ఆల్రెడీ 0 వచ్చింది 0 plus half m v square. So half m v square. Equation 1. So now the total mechanical energy that is Pe plus K at starting point A is equal to in the form of kinetic energy. In the form of kinetic energy for vertically projected body. That is equation 1. Now what happens is let the body has traveled from A to B over a displacement of say x. Let the body has traveled from A to B over a displacement of x. ఎప్పుడైతే బాడీ పై ప్రొజెక్ట్ చేస్తున్నాం వెలాసిటీ గ్రాడ్యువల్ ఇంక్రీజ్ అవుతుంది. సో లెట్ ద వెలాసిటీ అట్ B be v1 and gradually increase and finally at highest point it decreases. Now we have to calculate at B. Now at B. So at B what is P once again? mgh, that is mg into how much displacement has gone vertically? X. So mg into x. Now at B what is the velocity? It is changing to v1. So what is K now? K is equal to half m v1 square. So half into m into v1 square. Do you know v1 value? We don't know. So we have to calculate once again. That is by using v square minus u square is equal to 2as in upward direction. Here u is equal to v, v is equal to v1, a is equal to minus g and s is equal to displacement x. Substitute all these values in this one. What will get? V square, that means v1 square minus v square is equal to 2g minus a, because in upward direction a is taken as minus and s is nothing but displacement x. So from this ఎంత అవుతుంది v1 square? v1 square is equal to v square ఇటు పట్టుకొస్తే v square minus 2gx. Substitute this value here. Half m into v1 square ఎంత వచ్చింది? v square minus 2gx. Now put it inside. Completely take inside. So k is equal to half m v square. దీని కూడా లోపల పట్టుకెళ్ళిపోయింది మైనస్ హాఫ్ m 2gx. 2 get cancel. ఏం మిగిలింది మనకి ఫైనల్గా? half m v square minus mgx. This is K at B. కానీ మనకు కావాల్సింది ఏంటి? We want total energy at B. So I'll try to write I think on the top better. I'll write here. Okay? See here. So here I'll write at B total energy that is equal to P plus KE. Already P ఎంత వచ్చింది మనకి? mgx ప్లస్ K ఎంత వచ్చింది మనకి? హాఫ్ mv స్క్వేర్ మైనస్ mgx. మైనస్ mgx ప్లస్ mg గెట్ క్యాన్సిల్. ఏం మిగిలింది మనకి మళ్ళీ చూడండి? హాఫ్ mv స్క్వేర్. చూసారా? ఈక్వేషన్ 1 at point A total energy mechanical energy in the form of kinetic energy. Equation 2 at B కూడా మనకి ఏమొచ్చింది? We got as kinetic energy half mv square. That means already 2 points is proved. The total energy is constant. Now we have to prove the last point at highest point C. That also I will prove now. Okay? See here. Now last one. Let the body has traveled to highest point C. Highest point C. Therefore at C, what is potential energy? Highest point వెళ్ళిపోయింది ఎంత ఎత్తు వెళ్ళింది? హైట్ h. So what is potential energy? mg into h, that is mgh. Now what is k here? K is equal to half m v square. At the highest point, what is the velocity at the highest point? 0. Therefore, half into m into 0 whole square is equal to 0. So, what is total mechanical energy or total energy? PE plus K అంటే mgh plus 0. చాలా మంది ఇక్కడ వచ్చి ఆగిపోతారు. అదేంటి mgh వచ్చింది కాదు. Now, what the thing is, the body has traveled some displacement from A to C. A to C displacement వెళ్ళింది కాబట్టి పైకి. Therefore, initial velocity u is equal to v, final velocity v is equal to 0, a minus g, and s is equal to how much? S. These values again you have to substitute in the equation. V square minus u square is equal to 2as. Therefore, v final velocity 0 whole square minus u, initial velocity u square is equal to minus 2gh. Minus minus gets cancelled. ఎంత వచ్చింది మనకి? V square is equal to 2gh లేదా v square by 2g is equal to h. Now substitute the displacement in the above equation. Substitute చేస్తే ఇక్కడ ఏమవుతుంది మనకి చూడండి. I'll write it here. I'll write on the top. Better you can observe. See here. So finally what happened? You got. You can see I think. H ఎంత వచ్చింది? Displacement height v square by 2g. I'll substitute this value here. So therefore total energy is equal to mg into h. H అంటే ఎంత? V square by 2g. V square by 2g plus 0. Therefore total energy is equal to ఇక్కడ చూడండి g gets ఏం మిగిలింది మనకు ఫైనల్గా half m v square. ఈక్వేషన్ 3 because half m v square plus 0 is equal to again half m v square. చూడండి ఒకసారి ఈక్వేషన్ 1, ఈక్వేషన్ 2, ఈక్వేషన్ 3 at points ground level, intermediate point B, highest point C. Throughout the journey in vertically projected bodies, the total energy is remaining constant. Therefore, in the case of vertically projected bodies also, the law of conservation of energy is proved. Therefore, total energy is proved in the case of freely falling bodies and also vertically projected bodies. Okay. Now, after this, we will go for the main problems, that is concept called as chain problems or chain concept. Okay. So friends, let us go to the last part of work power energy in part 2, that is chain concept, because these are very very important in IPA, not only IPA examination, mainly it is asked in the MSET examination and NEET examination. Chain problems or chain concept. Chain concept. So in this chain concept, we have only 3 cases. We'll discuss the 3 cases. Case 1. See here. This is a table. On this table, we'll be asking first question. You can see L is the length of the chain. See, L is the length of the chain, capital L, and M is the mass of the chain, complete chain. Now what we'll be saying in the first case of chain concept is 1 by nth part of chain is hanging. 1 by nth and enta total length L ainappudu L by n. So this part is hanging from the table, and some small amount of friction is supporting that such that the chain is not falling down. Suppose if anybody pushes from back side, the chain will fall now. Some point is that means some part of friction part on the table is helping the chain which is not falling down because of that friction. But friction now I won't consider. In the last case I'll consider the friction point. So 1 by nth part of the chain is hanging and remaining part is on the table. Now what is the question is, first question you'll be asking the examination, that is what is the work done in lifting the hanging part onto the table? What is the work done in lifting the hanging part onto the table? అంటే కిందకి ఏదైతే వేలాడుతుందో దానికి పైకి లిఫ్ట్ చేయడానికి ఎంత పని చేయాలి? For this, the simple one is, see, work done is equal to U final minus U initial. Final potential energy minus initial potential energy. Final ఏంటి? ఇక్కడ బొమ్మ గీస్తాను మళ్ళీ నేను, draw a figure. Okay, this is the chain, initial. Now this part is lifted on the top. పైకి లిఫ్ట్ చేస్తాం. Okay, second part. So Now I'll take a reference line on the table. This I'll take as a reference line. I'll take this as a reference line. See here? Reference line, take it as on the table, not on the ground. On the table I'll take. Now the chain part is lifted onto the table. Now what is work done formula? Final potential energy minus initial potential energy. Okay? So how to get final potential? Because here the chain is on the table. Table మీద reference line తీసుకున్నాను కాబట్టి what is the potential energy? 0. So final, that is final potential energy is equal to 0 because the reference line is taken on the table. Okay? This is first part. Now what is initial? You have to calculate initial. Initial కి వచ్చినప్పుడు you can see this is first part of the chain and this is second part. First part is on the table కాబట్టి reference line సున్నా కాబట్టి for first part potential is 0. Okay? For first part potential energy is equal to 0 for first part because it is on the table. Now we have to calculate for the second part which is hanging down. ఇక్కడ ఒక చిన్న పాయింట్ అండి. You have to consider sign convention. That is above the table I'll take positive, below the table I'll take negative. Above the table reference line I'll be taking positive, below the table I'll be taking as negative. So here the chain hanging part is below the table. So how to get the potential energy hanging part? How to get? What is the formula? See, potential energy of 2 is equal to mgh. Now how to get the mass of this hanging part? See, already is given as L length mass is capital M. So 1 unit length mass ఎంత అవుతుంది? M by L. How much it is hanging? L by N. So into L by N. Unitary method. L length mass ఏమో క్యాపిటల్ అయినప్పుడు ఒక యూనిట్ లెంత్ మాస్ ఎంత అవుతుంది? M by L. L by N మాస్ ఎంత అవుతుంది? M by L into L by N. అప్పుడు ఎంత అవుతుంది? M by N. So this is the mass of the hanging part. Therefore, potential energy of part 2 is equal to M by N into G into H. H అంటే ఏంటి? పొటెన్షియల్ ఎనర్జీ డెఫినేషన్ ఏంటి? ఆల్వేస్ ఇట్ ఈస్ టేకెన్ ఎస్ సెంటర్ ఆఫ్ మాస్. సో mg into H అంటే ఎంత అవుతుంది? L by 2n. That means half of this value. L by n by 2. అంటే L by 2n. So what is the value here? mgl by 2n square. And this part is below the table. What is sign convention for below the table? Negative. So minus. So finally I got the value, okay, for the second part. So apply in the formula. Work done in lifting the hanging part onto the table is given by U final. U final and the 0 minus U initial. U initial, this one is 0. This one is 0 because on the table. Okay? And this one is minus mgl by 2n square. So final how much you will get? 0 minus into minus plus. ఇది అనగా 0 minus 0 minus 1 అంటే ఎంత అవుతుంది ఫైనల్? mgl by 2n square. So finally work done in lifting the hanging part onto the table is given by, what is the formula? Work done is given by mgl by 2n square. Very, very important formula. This formula is very, very important. M is mass of the entire chain. L is length of the chain. G is acceleration due to gravity, 9.8 or 10 meter per second square. N అనేది ఇక్కడ ఏంటి? హ్యాంగింగ్ పార్ట్ వాల్యూ. ఒకసారి అంటే 1/4, 1/5, 1/6. That value is nothing but n value. N is called as the hanging part. Okay? Okay, now. So in chain concept we have seen the first case, that is if some part of the chain is hanging down, what is the work done in lifting? That is given by mgl by 2n square. Please keep this formula is very, very important in doing numericals. Okay? Very, very important in doing numericals. N is the part of the chain hanging and remaining all the things are known. ఇందులో రెండో వెర్షన్ ఏమంటారండి? second question in this one is, what is the velocity of the chain just before slipping the table? This is the second case in chain concept. What is the velocity of the chain just before, just not after slipping, just ఇలాగ కింద పడుతున్నప్పుడు then velocity. So for that what we will do, same thing, and ఇక్కడ కూడా law of conservation of energy యూజ్ చేస్తాను. law of conservation of energy, which is nothing but mechanical energy. So ఈ కేసులో what you have to do is, the mechanical energy before is equal to mechanical energy after. See, in this case mechanical energy final is equal to mechanical energy initial. Now what is mechanical energy final? See here, kinetic energy final plus potential energy final is equal to kinetic energy initial plus potential energy initial. Same concept you are applying here. When the chain is just slipping down the table, is asking you what is the velocity. In such cases we have to apply law of conservation of energy, that is mechanical energy is constant, and mechanical energy final after slipping is equal to mechanical energy before slipping. Rendu equal cheste manaki will get the velocity value. Okay, so let us calculate kinetic energy final plus potential energy final is equal to kinetic energy initial plus potential energy initial. Okay, so ముందుగా ఏం కడదాం మనం, ఇనిషియల్ కట్టదామా, ఆల్రెడీ ఫిగర్ ఉంది కాబట్టి. సియర్ kinetic energy initial అంటే ఏంటి, చైన్ is at rest. when chain is at rest, what is the velocity? 0. so 0 plus రెండు రెస్ట్ లో ఉన్నాయి, ఈ పార్ట్ ఈ పార్ట్. now what is potential energy initial? already we calculated in the before case, first case. in first case the reference line 0 కాబట్టి, ఇది reference line అనుకున్నాం కాబట్టి, on the table for first part of the chain 0. second part already we calculated, what is the value here? mgl by 2n square. already we calculated for the second part, that is entadi mgl by 2n square. కానీ ఇక్కడ గుర్తుపెట్టుకోండి, mgl by 2n square, what it is, below the ground, I mean below the table. below the table means what you have to take it? minus, because above the table taken as plus, below the table it is taken as negative. This convention sign is very very important. above the table plus తీసుకోవాలి, below the table minus తీసుకోవాలి. okay, so chain hanging part below ఉంది కాబట్టి here plus into minus minus. this is what total kinetic energy initial plus potential energy initial. now coming to mechanical energy final. mechanical final ఎలా వస్తుంది, kinetic energy final plus potential energy final. జాగ్రత్త చూడండి, kinetic energy final అంటే చైన్ కిందకి జారుతుంది. then when the chain is slipping, what is kinetic energy? half m v square plus potential energy. when the chain is slipping, what happens? see, when the chain is slipping down, what is the total length now? L. so what is the mass now? center of mass here half of the length and L by 2. so potential ఎంత అవుతుంది ఇక్కడ? what is the potential? m g center of mass L by 2. and please make a note, mg L by 2 is coming down again below the table, so this will become minus. so therefore I think you can't say, I'll write it here, the remaining part, half m v square plus into minus minus. this minus if you take to this side, what happens? plus. so that is equal to plus, that is mgl by 2. ఈ మైనస్ చూడండి, ప్లస్ ఇంటూ మైనస్ ఇస్ మైనస్. దిస్ మైనస్ ఇఫ్ ఐ టేక్ టు రైట్ సైడ్ బికమ్స్ ప్లస్. సో mgl by 2. ఆల్రెడీ హియర్ వాట్ ఈస్ లెఫ్ట్ ఓవర్? 0 అండ్ ప్లస్ ఇంటూ మైనస్ మైనస్. ఈ మైనస్ మామూలు ఉంటుంది. మైనస్ mgl by 2n square over almost 2 cancel, mass 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 cancel. this is capital M. okay, now what is left over? v square is equal to pine gl, if you take common, 1 minus 1 by n square. but I want v. what is the case here? what is the velocity of the chain just before slipping the table? so v is equal to given by root over g into l into 1 minus 1 by n square. so this is the formula you have to remember for numericals in MSET. g 9.8 or 10 meter per second square. l length of the chain given, and 1 minus 1 by n square is the fraction part. n is the part which is hanging from the table. n is ఎంత పార్ట్ కిందకి వేలాడ తీసబడిందో టేబుల్ నుంచి, దట్ ఈస్ n వాల్యూ. అంటే ఒక్కోసారి అంటే 4వ వంతు, 5వ వంతు, 5th part, 4th part, దెన్ యూ టు పుట్ ద వాల్యూ దేర్. 4th part అన్నప్పుడు n ప్లేస్లో 4 పెట్టాలి, 6th part అన్నప్పుడు n ప్లేస్లో 6 పెట్టాలి. సో So this is how you will be calculating the velocity of the chain just before slipping. Let us go to the last part of this chapter now. Okay, last part. Copy it? Right. In this chain concept, we are having only one point left over, that is the last part. And sometimes in MSET it will be asking, that we will discuss, and with that it will be completed. Third case, last part. See here, last part ఏమీ లేదండి, జస్ట్ చూడండి ఏమో అడుగుతాడంటే మీకు. See, in the last part, what he will be asking is friction is considered here, mu. That means now you see on the table, chain is hanging. Okay, here I'll take away this L by N and I'll take some other value. Chain is hanging. Now let X part is hanging. Case 3, let X part of the chain is hanging. And what is the remaining part here? L minus X. If total length is L, X is hanging అంటప్పుడు బ్యాలెన్స్ ఎంత ఉంటుంది? L minus X. And same way, ఇక్కడ ఏంటంటే ఆల్రెడీ L length mass capital M, 1 length mass M by L, 1 length mass unitary method M by L, X length mass ఎంత అవుతుంది? M by L into X. So this is the mass of the hanging chain. In the same way for L by X, in the same way L by X, M by L into L minus X. So this is the value mass for this one, M by L into L minus X. So this is the mass of the chain on the table, and this is the mass hanging part from the table. Now which is helping this chain without slipping from the table? Which is helping? Small friction, small amount of friction is there on the table, because if you push from back side now slightly, the chain will come down. So that small amount of friction is helping. So we'll try to calculate that value here. See here, we already know F is equal to mu into N. That means frictional force, because frictional force is in this direction. Opposite force, friction in this direction. Weight, downward direction. This is weight. So which is helping this weight, not pulling down, this friction. That means this friction is balanced by weight. And F is equal to mu N is balanced by weight. Which weight? This hanging part chain. So mu friction into normal force. What is the normal force? Weight of this one. What is the weight? M by L into L minus X. mg. This is the weight. Weight of the table, weight of the chain on the table. So this is balanced by weight of the hanging part. What is the hanging part weight? Mass is M by L into X into G. So these two forces are balanced now. These two forces are balanced now. Now see, G, M by L, ఏమీ నింది ఫైనల్గా చూడండి, లోపల తీసుకెళ్ళండి. mu into L minus X is equal to, how much is left over here? X. Okay, mg, that is M by L into X, mg, weight. Okay, right. Now what is left over? Mu into L minus X is equal to, right side X is there. Now take inside mu into L minus, okay, mu into L minus, take this one inside, mu X is equal to X, or mu into L, take this one to right side and take X common, X into 1 plus mu. Now finally what you got here? ఏం మిగిలింది మనకి చూడండి, L mu by, you can see X part is hanging, X by L is equal to, I can write like this in this fashion, see, check it whether right or wrong. X by L is equal to mu by 1 plus mu or mu plus 1. Check చేసుకోండి ఒకసారి. mu L X into 1 plus mu. So right. So this is the main formula for when friction is also given. That means X is the hanging part from the table, L is the length of the chain, original chain, mu coefficient of friction, and 1 plus mu. Again, 1 is a factor, mu is again friction value. So if that fellow For example, mu is given as say 0.25. Let us assume. Let mu is given by 0.25. This value substitute here. 0.25 by 1 plus 0.25. Suppose x is also given, some part is hanging, like 1/4 is hanging. You can put the value here. Or 25%, some percentage will be giving. 25% is hanging. You can put the value here. So finally, you can utilize this formula. X by L, hanging part by original length, is equal to coefficient of friction by 1 plus coefficient of friction. If he gives any values, directly you can substitute in this formula. Friction formula, that is mu value and also x part and also L. Clear all of you? This x is nothing but hanging part. Hanging part. This is L is total length. X అనేది ఇక్కడ ఏంటి, ఎంత భాగం అయితే కిందకి వేలాడదీసబడిందో టేబుల్ మంచి, that x is called a hanging part and L is the original length. Okay, so like this we can discuss about different cases in chain and chain concept. By using this chain concepts, you can solve many problems in MSET and also NEET problems. Okay, clear now? And we'll be meeting again in the next chapter, that is center of mass and collisions.